Okay, can you see the slides?
Yes, sir.
Okay, I'm changing. Please confirm. Are you seeing the change slide?
Yes, sir.
Okay. Okay, welcome to Department of Chemical Engineering, Banastali Vidyapeeth. We are on CHT 305 Chemical Technology Lecture 33. Time to feel fresh. Summer has come, sweating all over, want to feel fresh, relax. Time to pick up soaps and detergents. We all know about soaps, but just a quick recollection. You all know that soaps are the potassium or sodium salts of long chain fatty acids like oleic acid, stearic acid, palmitic acid, lauric acid, myristic acid, while detergents are generally alkyl benzene sulfonates. One quick difference between soaps and detergents is soaps, you can say, are more natural organic products, whereas detergents are synthetic made ones. You can't wash clothes with soap and you can't take bath with detergent. That's known. You know what will happen. Okay. But soaps, these are all acids, fatty acids, oleic acid, stearic acid, palmitic acid, lauric acid, myristic acid. So many of the, say, coconut oil, etc., they contain some of these oils, right? Fatty acids. So making a soap is nothing but converting this fatty acid into potassium or sodium salt. These are not long chain fatty acids. So soaps consist of a COONA. Remember, when you say fatty acid, it will be COOH. Okay. So the H is replaced by sodium or potassium. So COONA or COOK. Right? COONA or COOK group is attached to a fatty acid having a long alkyl chain. Remember, alkyl chain, not aromatic, alkyl chain. While detergent consists of SO3Na. Remember, soaps have a COONA, whereas detergents in their chemical structure will have a SO3Na group attached to a long alkyl chain. While soaps are derived from natural sources such as vegetable oils and animal fats, and hence they are biodegradable. Detergents are synthetic derivatives which can form a thick foam that causes the death of aquatic life. So detergents not only clean your dirty clothes, but they can also clean the aquatic life, kill the fish, etc. Soaps are not effective in hard water and saline water, while detergents do not lose their effectiveness in hard water and saline water. So you know the difference between hard water and soft water. So soaps work very well in soft water. Taking bath, good foam, you feel nice. But if the water is hard, the soap will not form lather. You will feel as if you are scratching your body with a stone because the lather is not formed in hard water by soap. But detergents, कुछ भी हो हार्ड वाटर है saline water है salt water है फिर भी foam बनता है. There's a major difference between soaps are in general natural organic sources such as vegetable oils and animal fat and are biodegradable. Detergents are this SO3Na etc. are made by us in the factory, right? So they are not biodegradable and they accumulate and may lead to death of fish and other marine aquatic organisms. Right. Now, coming to soap, soaps are used for human comfort. After a long day, you want to, feel fresh. You have a bath with a nice soap. Cleanliness and for industrial use. So this industrial use is the different. In that case, it becomes more or less a detergent. Okay. And soap is a surface active agent or a surfactant. They bring forth the action of removing the dirt by surface action. We'll see what it is. Every soap molecule has a hydrophilic part and a hydrophobic part. You know the meaning. Hydrophilic means water friendly, hydrophobic means water enemy. Right? When you see this part of the soap molecule will turn its face away from water, whereas the hydrophilic part of the soap will put its face towards the water. The hydrophilic part of the soap is carboxylate head group and hydrophobic part is aliphatic chain. Remember, we told that soaps are potassium sodium salt of long chain fatty acids. So the hydrophobic part is the fatty acid part and the hydrophilic part is the COONA part. The dirt or grease is cleaned by key mechanism. So the dirt gets attracted and that is how it gets removed. Most marketed bar soaps contain titanium oxide as an opacifier or as a whitener to bring brightness. A variety of dyes are also used to produce color soap. Today you see in the market, you get soaps of all colors you can think of, right? Unusual colors also, right? Sodium, so that is all by the dyes used. Sodium salts are called hard soap, whereas potassium salts are soft soaps. This is also a difference. Sodium salts are called hard soap, whereas potassium salts are soft soaps. Let's look at the reactions. First reaction is what is known as fat splitting reaction. Fat splitting reaction. Remember, this is how the fatty acid looks like. RCOO, this 3 it should be in the subscript. RCOO 3 times C3H5, the long chain fatty acid, plus 3 times water, forms 3 times RCOOH fatty acid and glycerine. Right? So the triglycerides with water form fatty acid and glycerine C3H5OH3. Next comes the saponification reaction. The fatty acid with a base like NaOH or KOH will form RCOOM. M may be sodium or potassium and water. Okay, so you see the soap making is a very simple two-step process. First, the triglycerides combine with water and form fatty acid. That is a fat splitting reaction and form glycerine. And the fatty acid reacts with the base to form bases KOH or NaOH. Right? And it forms RCOOM. M may be K or Na depending upon whether you have used caustic soda or KOH. Okay, plus water. So you can see the M comes into H and the H goes here, so water is formed and RCOOH becomes RCOOM. So that is the simple reaction that goes. Let's look at a simple flow sheet, how it is made. So input fats, fatty acids, all this folic acid, steric acid, all these things, fatty acids. Hot water, another input. fatty acid, fat. Catalyst is typically added because in doing this fat splitting, a catalyst plays a good role, and usually the catalyst used is zinc oxide. We'll come to it. First, you understand the flow sheet. So, fats mixed with the catalyst enters into the first equipment. Let's call it as hydrolyzer. Why we are calling it a hydrolyzer? Because water is being added and the reaction is taking place. Okay, so this equipment is known as a hydrolyzer. So it is operated at 230 to 250 degrees centigrade, 40 to 45 atmosphere pressure, water. So remember, the first reaction has to take place, and catalyst helps in making this reaction faster. So usually the catalyst uses zinc oxide. Then comes a flash tank. By now you should know what a flash tank is. The This is operating at high pressure. Flash tank is release the pressure. So when you release the pressure, water is removed and the remaining material, there is a vapor liquid separation due to the pressure release. So water gets removed and the remaining material enters into the next step, which we will call it as vacuum still. Right? It is operated under vacuum. The reason being, for easy separation. And because at high temperature, this may deteriorate. Remember, you have formed fatty acid and it has to combine with the base to form this. So, if you apply too high a temperature and pressure, then the fatty acid may split. So, the vacuum still, you get the fatty acid product here, fatty acid product. Okay, I can get it as the fatty acid product, or I can take it into a mixture where I say I add caustic soda for the second reaction. Because remember, the first reaction, the triglycerides break into fatty acid and glycerin, and next the fatty acid combines with the base to form this. So the fatty acid combines with caustic soda and it is blended. And after this, there are three options. The soap is made, you can say, when the blending is done, the soap product is made. Now, I may make it into bar, soap bar, or I may make it into chipping rolls, or I may make it into powder. So, I have all the three options. I may make a soap bar, or I may make into small flakes of soap, chipping roll, and the third one is I can make it into a soap powder. And there is another thing. Remember, you said that we are forming glycerine also. Glycerine. Now, see, from the top product, the fatty acid is going. That we will call it as a. So the important parts of the process are, this is the hydrolyzer. Let's call this as the fatty acid stream, and the bottom one as the glycerine stream. So on top, the fatty acid has gone. Bottom of the hydrolyzer goes to ion exchange and then goes into uh, what is that, triple effect evaporator, right? Because the glycerine may have water, so the water has to be removed and the glycerine must be concentrated. So a triple effect evaporator is done and the water is converted into steam, and then again it goes into a vacuum still. This is like a distillation column operating under vacuum, and we can achieve vacuum by mixing with steam, right? So from here the glycerine comes out. The direct product you may get is 99% yellow glycerine. The glycerine is yellow in color. Now, if the glycerine is taken to a mixture and activated carbon is added, right? See, the yellow color is because of some coloring chemicals, right? So, what I can do is, the yellow glycerin, that is how your, what is that, pear soap look, right? That is glycerin soap, you know it, right? So, other way is, if I want to remove the yellow color, I take it to a mixer and add activated carbon, and the chemicals which bring the yellow color will get stuck with the activated carbon, and then it is filtered and I get 99% white glycerin. Glycerin is used for face wash and cleaning the face mask, etc. Okay, so this is about the flow sheet. So you have the fat coming mixed with catalyst, put into hydrolyzer, and hot water is added for the fat splitting reaction to take place. The catalyst zinc oxide, right, helps in the fat splitting reaction. Okay, and then you have a top product and a bottom product. The top product processing is known as the fat splitting stream, and fatty acid stream block, and the bottom part is the glycerine stream block. Okay, so this is about it. Let's see the details. What happens in the hydrolyzer? Fat and catalyst zinc oxide is mixed together and enter the hydrolyzer. Hot water is added here. Hot water is added here. Fat with zinc oxide catalyst is mixed and put into the hydrolyzer. Hot water is added. Intimate mixing required for water, oil, immiscible phase. So some mixing has to be done, and water has 10 to 15% solubility in oil and fats. Temperature is maintained at 230 to 250 and pressure at 40 to 45. The fatty acid stream is produced as a top product. Top product is fatty acid. This is a fatty acid. And glycerin is produced as bottom product. Glycerin is produced as bottom product. So this is a fatty acid and this is a glycerin. The glycerin, of course, has to be concentrated, and a triple effect evaporator is used, and then goes to a vacuum seal from which some impurities may be removed, and uh, what you get is 99% yellow glycerin. And if you want white glycerin, take it into a mixture with activated carbon and do filter it. You get 99% white glycerin. How? Because the color chemicals which add this yellow color have got stuck in the activated carbon and have got removed. Okay, so this is about the hydrolyzer. Then you come to the fatty acid stream. You have a flash tank, fatty acid from the hydrolyzer. You please recollect this flash tank. Enter the steam flash tank to remove water and concentrate the fatty acid. Okay, vacuum still. Vacuum still. So the concentrated fatty acid enters the high vacuum still. Jet ejector is used to generate vacuum in the still. Wastes are separated from the bottom, and fatty acid is also taken out as a marketable product. I may use fatty acid itself as a product, or I can mix it with NaOH or KOH and blend it and make it into bar soap or chips or soap powder. Then comes mixer. Fatty acid produced from the vacuum seal is pumped to a mixture. NaOH or KOH is mixed in appropriate proportion and mixed thoroughly. After mixing, a viscous mass is produced. Blender. Blender. The viscous mass from the mixture is sent to the blender. Now here, no, look, you want a soap with a flavor, add scent, some antifungal, antibacterial. They are all chemicals are added and is mixed in the blender. The blender removes the solid mass, which is sent to either the chipping roll to manufacture soap strips, spray dryer to get soap powder for manufacture of liquid soap, and bar press stock to press and cut the viscous mass into bars of soap. Then comes the glycerin stream block. So I told you that the top half is the fatty acid stream and the bottom half is the glycerin stream. So ion exchange. 15 to 20% glycerin along with impurities from the hydrolyzer goes for ion exchange. Here salt and color is removed from the glycerin. So the purpose of ion exchange is to remove these material, salt and color causing material are removed from the glycerin. Then goes to triple effect evaporator. The product stream from ion exchanger is sent to triple effect evaporator. The glycerin solution is concentrated in the evaporator. Concentration. Okay. Then mixture. For removing color, yellow glycerin is treated with activated carbon filter. Activated carbon is separated from the solution. 99% white glycerin is produced. The yield is 30 to 35 kg per ton of soap produced. That's about soaps. Now let's come to detergents. Detergents have better surface tension lowering action than soap. Remember, detergent works even in hard water as well as in saline water. Soaps will not work in hard water and saline water. Due to excessive foaming, it is unable to reduce organic content of sewage effluent. So this is a problem with detergent. Biodegradation of detergent is an important environmental factor. Detergents react with hard water ions. Detergents are of 4 types: anionic, cationic, non-ionic, anionic, cationic, non-ionic. The last one is amphoteric. New term, amphoteric, we'll see. So the main problem that appears in the use of detergents is that if their hydrocarbon chain is highly branched, then bacteria cannot degrade this easily. Point to be noted. Right? So in detergent, you have a very highly branched set of organic chemicals and bacteria finds it too difficult to attack the highly branched one. Right? Slow degradation of detergent lead to their accumulation. So this is a headache with detergents. Now let's see about each of them. That is the 4 detergents: anionic, cationic, non-ionic, and amphoteric. Anionic detergents, they are sodium salts of sulfonated lengthy chain alcohols or hydrocarbons. Anionic detergents typically have negatively charged sulfate group as the hydrophilic head. Sulfate group means, remember, SO3. They are widely used due to cost and performance as laundry detergent, dishwashing liquids, and oven cleaners. So, detergents in action. Anionic detergent. Example, CH3, CH2 11 times, OSO3Na, which is sodium dodecyl sulfate. CH3, CH2 11 times, C6H4SO3. Na plus. Sodium dodecyl benzene sulfonate. So sodium dodecyl sulfate, sodium dodecyl benzene sulfonate are examples of anionic detergents. Then comes cationic detergents. Cationic detergents, see, anionic detergents and cationic detergents. They have a positively charged ammonium group. The cationic detergents are the part of ammonium salts of amines through acetate, chlorides, otherwise bromides or as anions. Lengthy hydrocarbon chain in addition to positive charge and nitrogen atom in process of cationic detergents. These parts are known as cationic detergents. The famous cationic detergent is cetyl trimethyl ammonium. So cetyl trimethyl ammonium is a cationic detergent that is used in hair conditioners, not air conditioners, hair conditioners. Cetyl trimethyl ammonium. Also, you see, the cationic detergents contain germicidal properties. Wow. And are expensive. Yes, naturally. These are used in limited supply only, limited use only. Used for cleaning plastics, hair shampoos, nappy washes, fabric softeners, and conditioners. Example of these cationic detergent, CH3, CH2 11 times, NH3 plus Cl minus. Dodecyl amine hydrochloride. It's a cationic detergent. Also CH3, CH2 15 times, N CH3 thrice, Br minus. Hexadecyl, hexadecyl trimethyl ammonium bromide. This is an example of cationic detergent. Then comes non-ionic. Non-ionic, this non-ionic is rules the dishwashing detergents. Wow, dishwashing detergent, Vim, etc. The cleaning action method of this type of detergent is same as that of soaps. The non-ionic is like typically work like soap. The non-ionic is mainly used in the remove grease and oil by micelle structure. This is a new term now, micelle structure. Now, to make you understand, let me explain you. You have just seen the cleaning action is same as that of soap. Now you know that soap has got a hydrophobic part and a hydrophilic part. Clear, no doubt. So when I add a soap in water, what happens? The hydrophilic part is inside the water and the hydrophobic part is outside the water. Okay, hydrophilic, water loving. So it is inside the water, and the hydrophobic, water hating, is above the water. Now I increase the concentration. Then what happened? Some more hydrophilic goes inside, and some more hydrophobic remains on the surface of the liquid, right? Of say water, right? Because assume that the vessel has got water. So when I add a soap, the hydrophilic part is inside the water and the hydrophobic is outside the water. Now, as I keep on increasing the concentration, then what happens? More and more hydrophilic goes inside and hydrophobic is remaining on the surface. But you will reach a concentration at which the surface is full of hydrophobic material. There is no more place for soap to enter and form hydrophilic material at all. So what happens then? Then something must happen, and that's what happens, micelle formation. So imagine as you increase the concentration, when the surface becomes saturated with hydrophobic material, then that is known as the critical concentration, right? Because after this, any more soap you add has no place to go, right? So that concentration is known as critical micelle structure, CMC, right? Or critical micelle concentration. CMC is critical micelle concentration. Now, if I increase the soap beyond the CMC value, then where will the hydrophilic part go? Now is the micelle formation happen. Micelle is something looking like a let's say the coronavirus, right, where the hydrophobic part is like a bubble, right? The hydrophobic part will be inside the bubble and the hydrophilic part will be outside the bubble, right? Assume you have a bubble in which the inside of the bubble is all hydrophobic part of the soap and the outer part of the bubble is all hydrophilic. That is known as the micelle formation. Right. Now remember, if instead of water you have another organic substance, then the reverse micelle will form. Hydrophilic will be inside the micelle bubble and the hydrophobic will be projecting outside. Okay. So this is used in car shampoo, car wash, dishwasher detergents and cosmetics. Example, pentaerythritol palmitate, CH3, CH2, 14, COO, CH2C, CH2O thrice. Pentaerythritol palmitate. Also, you have sodium tripolyphosphate, STPP. Sodium tripolyphosphate, STPP. It is an inorganic compound with formula Na5P3O10. And the sodium salt of the polyphosphate pentaanion is used as a component of a wide range of domestic and industrial products, particularly detergent. See how it is formed: sodium polyphosphate, sodium tripolyphosphate. 5 times Na2CO3. Right? Na2CO3, sodium carbonate. Right? Solvay process, don't forget. Na2CO3 plus phosphoric acid. You get this Na5P3O10. 5Na P3O10. 5Na used here, 5Na has come out here. Okay? Plus water and carbon dioxide. This is sodium tripolyphosphate. So I am making a general method to make synthetic detergent. Alkyl benzene with oleum will form alkyl benzene sulfonate. Tallow fatty alcohol plus oleum, you will form fatty alcohol sulfate. Sulfonate with sulfide and NaOH, you get sodium salts. Sodium salt plus builders, you get detergents. Builders are special chemicals to bring the required action. Now let's come to some of the major soap manufacturers. Godrej, Fair Glow, Synthol. Most soap manufacturers, remember, they make soap which is more for the women and soap which is mainly for the men. So Godrej uses Fair Glow for the women and Synthol for the men. So Synthol is now available for girls also. RB Health. RB stands for, remember, there was the earlier Reckitt and Coleman, the big, international major, Reckitt and Coleman. Then it became Reckitt and Benacer. So Reckitt and Benacer Health makes a Dettol. Ultimate. Everyone knows the Dettol. Dettol soap. Okay, Dettol liquid. Okay, Wipro Consumer Care, Santur soap, famous ad. Ma, everyone surprised. Wow, ITC. From cigarettes, they moved into biscuit making, vegetable oil, sunflower oil, etc., and also into soaps. ITC made Fiamma, Vival, Savlon, big names. Jyoti Labs. Jyoti Lab, many may not know, but Ujala wala hai na, Ujala, to make your uniform whiter than white, whiter than white. Ujala drops. So Jyoti Labs are the manufacturers of Ujala. Now they have Margot soap in their kitty. I think earlier Margot soap was a Tata product and it has changed hands and gone to Jyoti Labs. Okay, so Jyoti Labs, another name, the Margot, and of course they are famous for their Ujala also. Hindustan Unilever, सबसे बड़ा Lux, Lifebuoy, Liril, et al. I am writing. I think you students know all the soap manufactured by Hindustan Unilever. I am not getting into it. Then there are 7, 8, 9, 10, some more names which are there. You might not have heard, but they are big exporters. Vasa Global, I think Bombay headquarters. Ivory Soap Works, I think also Bombay. Swati Soap, maybe Ahmedabad, I think. Balda Industries, not sure. Kavit Soaps could be Ahmedabad. Bombay, Ahmedabad, this Vasa, Ivory, Swati, they all are also named, but they export uh, to other countries and they make those soap strips and many such products. So these are some of the soap manufacturers. I think it's time for us to have a quick look at some of the videos. Let me see whether I can get them to play for you. Just hold a minute. Uh, oh, I'm not getting this. Wait. Just hold a minute, please. Yes.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct.
Hi, this is Terry with Tree Marie Soapworks. Today I'm going to be showing you how to make this bar. It's a goat milk soap and it's all natural. For this bar, I did not add any
Hold a
colorant
minute.
or any fragrance. Stay tuned to the end of the video and I'm going to give you a few tips and also tell you about the white spots that form in goat milk soap often, and I want to explain that a little bit. Also, I'm going to be offering
Are you
this
able to see
recipe
the
on
video?
my
Hello?
website for purchase if you would like. So
Yes,
I will
sir.
give you links for that. I replaced all of the water in the recipe with goat's milk. I use
Hello,
raw
are you able
goat's
to see
milk,
the video?
and goat's milk has to be frozen
Yes,
to
sir.
add it to the lye because it'll
Yes, sir.
Okay, Hi, this is Terry with Tree Marie Soapworks. Today I'm going to be showing you how to make this bar. It's a goat milk soap and it's all natural. For
This
this
is a very
bar, I did not
interesting
add
soap.
any
Just
colorant
watch.
or any fragrance. Stay tuned to the end
Made
of the
with
video
goat milk.
and I'm going to give you a few tips and also tell you about the white spots that form in goat milk soap often, and I want to explain that a little bit. Also, I'm going to be offering this recipe on my website for purchase if you would like, so I will give you the links for that. I replaced all of the water in the recipe with goat's milk. I use raw goat's milk, and goat's milk has to be frozen to add it to the lye because it'll scorch otherwise. Okay, let's get started. Make sure that you are all geared up for safety and measure the frozen goat's milk and the sodium hydroxide. If you have never made cold processed soap before, milk soap isn't really the soap you want to start with because of the heating up that's involved because of the sugars. So you can scorch the
So
milk pretty
goat milk with
easily.
sodium
So I would
hydroxide.
recommend if you start with something, start with a simple recipe that uses water as the liquid. Once you're finished measuring your sodium hydroxide, add a little bit of that to your frozen goat's milk. The goal here is to add the sodium hydroxide
mixing.
gradually so that the temperature stays relatively low. And to help keep your temperature low, I'm going to show you how to make an ice bath. Just set your pitcher in a bowl that's a little bit larger and surround it by ice cubes, and then pour enough water in there to make it barely float or not float at all. Be careful that it doesn't float too much or it'll be unstable. Next, just keep gradually adding a little sodium hydroxide and stir very well in between, and then we're going to give it a little break. And while we're gradually adding the sodium hydroxide, I want to talk a little bit about the color of the goat's milk. It's going to turn a little bit of a yellow color when it's starting to scorch, and it usually gives off kind of an ammonia smell. Now, there's nothing wrong with this. You can totally use it. But for this recipe, since I'm not adding any color, I wanted to keep it as light as
You
possible.
can make at home also.
To give you an idea of an acceptable shade of yellow that's totally fine, I'm going to show you this picture. Okay, in this photo, I'm straining the goat milk. I wouldn't get it any darker than this, but this yellow is totally acceptable. At this point, I add a little more, but then once I stir this, you can see that the ice cubes are almost melted, so this is a good time to give it a little break and to let it cool down again.
Thorough mixing.
I try to keep the temperature below 70 degrees Fahrenheit or 21 degrees Celsius. Next, cover the sodium hydroxide and set it aside. Next, I'm going to measure my sodium lactate, and I just add it to the batch right away because it's already cool. After you get the sodium lactate stirred in, just set that aside with your sodium hydroxide. Next, measure the palm kernel flakes, and these have a melting point of 102 degrees Fahrenheit and 78 degrees Celsius. So measure these first and get them melted, and then add the coconut oil and the lard.
Coconut oil.
Lard is a fairly balanced oil. What I like about it is it has about the same amount of palmitic and stearic acid as it has oleic acid. So the palmitic and stearic acid cause it to be a hard bar, and it's a very stable bar. It's not a drying bar. And the oleic acid in it makes it moisturizing. So this is a really nice oil, and lard also slows down acceleration. And this recipe is a very slow-moving recipe. Next, microwave those if necessary, and then we'll add a little more sodium hydroxide to our goat milk. When it's mixed in completely, set it aside again and start to measure your liquid oils, starting with your avocado oil, then your castor oil, and
Wow,
then
avocado
your olive oil. The reason I start with the avocado oil is because it's a thinner oil, and if I go over, I can easily put that back because I haven't measured anything else in there. Then the castor oil is a thick oil, so it's pretty easy to get that right on and not go over. And then the last oil is just the olive oil, and that one is easy just to top off with a squeeze bottle.
Olive oil also, wow.
This brilliant device stops expensive internet and gives you super fast Wi-Fi anywhere and anytime for a fraction of the cost.
I microwave these oils until they're almost melted, and then I just stir the rest of the way, and I add my cocoa butter. These are cocoa butter pastilles, and they're from Brambleberry. I really like working with them, but you can use any kind of cocoa butter with this. If you don't want it to have a chocolate smell, make sure you use the deodorized kind. At this point, add some more sodium hydroxide and try to keep your temperatures below 70 degrees Fahrenheit or 21 degrees Celsius. Next, I stir in my cocoa butter, and if it needs a little more microwaving, I microwave it until it's barely melted. After that, just add the remaining amount of sodium hydroxide and set aside.
I think it goes on, and let's skip forward.
It is harder for it to
There it is,
overheat.
yeah.
Remember, less water is harder to overheat, and more water is easier to overheat. Okay, this is the next day, and I love how this soap came out. Before I cut my loaf into bars, I bevel the long edges first just to make it easier. And then I mark my bars, and I'm marking, in this case, every inch, but I put it on a slant so I can get them equal. If that doesn't make sense to you, I have a video on that. So you can click on the eye in the upper right corner and find that video. The rest of this is pretty self-explanatory. The first thing I want to talk to you about is the white spots that sometimes form in milk soaps. Sometimes the white spots can be stearic spots, but most of the time when you're troubleshooting it, I feel like they get misdiagnosed as stearic spots. A lot of times they don't form right away, they form as the bar is curing. Check out the bar above. This soap I made a long time ago, and I still kept some bars because I never did sell it. But originally I thought it might be lye or something like that. But I did
Very
the zap
luxurious
test, and
looking.
there's no zap when you touch your tongue to it. And
I think
also, I just
somebody
did it
may
again
think it
on
is
my
a
soap that
cake
I
piece
have.
and take a
So I know
bite.
it wasn't lye heavy or anything like that. But this was a buttermilk soap. The only oils used were olive oil and coconut oil. And olive oil and coconut oil don't have much serum together. It would just make them a lot less noticeable. And also, stick blending helps. If any of you that have a science background that you're interested in being on the list for when the recipes come out. And if you've asked to join the group and haven't been accepted, just make sure you go back and answer when I post my next video. Thank you to those of you who have checked out my website and also the ones that have placed orders. I really appreciate it. Thank you so much for joining me today, and thank you for sticking with me until the end. And
Goat milk and oats. I think you all should try, some of these, for time pass. They're showing a detergent making. See, those who want to be entrepreneurs, have a look at this video for a minute.
डिटर्जेंट पाउडर मैन्युफैक्चरिंग बिजनेस। डिटर्जेंट पाउडर साफ सफाई के लिए बहुत ही आवश्यक वस्तु है। कपड़ों को साफ करने के लिए डिटर्जेंट पाउडर का ही इस्तेमाल होता है। डिटर्जेंट पाउडर मैन्युफैक्चरिंग उद्योग एक ऐसा लघु उद्योग है जिसे आप कम लागत में आसानी से शुरू कर सकते हैं और अच्छा मुनाफा भी कमा सकते हैं। बड़े इन्वेस्टमेंट के साथ ऑटोमेटिक मशीन और पैकिंग मशीन के साथ भी इसे शुरू किया जा सकता है। चाहे कोई भी व्यवसाय हो, वो तब तक सफल नहीं हो सकता जब तक अच्छी योजना के साथ शुरू ना किया जाए। आज अपने चैनल के माध्यम से हम आपको बताने जा रहे हैं डिटर्जेंट पाउडर मैन्युफैक्चरिंग के बारे में। आईआईटी का यही प्रयास रहता है कि वो इंडस्ट्रियल डॉक्यूमेंट्रीज के जरिए आपको व्यवसाय की पूरी योजनाओं की जानकारी से अवगत कराए। ऐसे ही और विशेष उद्योगों के बारे में और बिजनेस आइडियाज और इंडस्ट्रीज के बारे में जानने के लिए हमारे चैनल को सब्सक्राइब करें और बेल आइकन को प्रेस करके नोटिफिकेशंस प्राप्त करते रहें। डिटर्जेंट पाउडर मैन्युफैक्चरिंग के लिए कई तरह की आवश्यक रासायनिक सामग्री का इस्तेमाल किया जाता है, जैसे सोडा ऐश, सॉल्ट, डोलोमाइट, SLS पाउडर जिसे सोडियम लॉरेल सल्फेट भी कहा जाता है, मेटासिलिकेट, सिलिका पाउडर, DMX पाउडर, CBXS पाउडर, लाप्सा, कलर ग्रैन्यूल, परफ्यूम और ब्राइटनर इत्यादि। डिटर्जेंट पाउडर की पैकिंग के लिए पॉलीथीन बैग्स का इस्तेमाल होता है। बात अगर एरिया की करें तो डिटर्जेंट यूनिट लगाने के लिए 1000 स्क्वायर फीट से लगभग 1500 स्क्वायर फीट एरिया की आवश्यकता होती है। साथ ही जरूरत होती है बिजली और पानी आदि की व्यवस्था की। यूनिट के रेगुलर मेंटेनेंस के लिए इलेक्ट्रीशियन और मिस्त्री की भी आवश्यकता होती है। इस यूनिट के द्वारा 100 पैकेट्स का बैच लगभग 20 से 25 मिनट में तैयार हो जाता है, जिसको तैयार करने के लिए बस 2 से 3 लोगों की जरूरत होती है। अतिरिक्त लागत के रूप में विनिर्माण गतिविधि में जनरेटर व इसके लिए पेट्रोल, परिवहन आदि का भी उपयोग होता है। अगर आप 100 किलोग्राम बैच कैपेसिटी के लिए ऑटोमेटिक या सेमी ऑटोमेटिक रिबन मिक्सर मशीन, क्रेज स्क्रेमिंग मशीन और रोटेटरी पैकिंग मशीन खरीद सकते हैं। रिबन मिक्सर मशीन से रॉ मटेरियल को मिलाया जाता है और स्क्रेमिंग क्रेज मिल मशीन की सहायता से बने हुए डिटर्जेंट को और भी बारीक बनाया जाता है। फिर सीलिंग पैकिंग मशीन से पैकेट्स को सील कर दिया जाता है। और आइए अब जान लेते हैं डिटर्जेंट पाउडर बनाने की प्रक्रिया के बारे में। इस प्रक्रिया में सबसे पहले रॉ मटेरियल मिक्सर में सोडा ऐश, सॉल्ट और डोलोमाइट को मिक्स करते हैं। फिर उसमें लाप्सा, अल्ट्राशाइन के लिए CBSX पाउडर और झाग के लिए SLS पाउडर मिलाते हैं। उसके बाद क्लीनिंग के लिए सोडियम, मेटासिलिकेट, शाइन के लिए DMX पाउडर, ड्राइनेस को बनाए रखने के लिए सिलिका पाउडर को मिक्स करके उसमें कलर ग्रैन्युल्स डालते हैं। इसके लगभग 5 मिनट बाद मिश्रण को मिक्सर से निकालकर बकेट कन्वेयर में डाला जाता है। उसके बाद क्रेज मिल से गुजरते हुए ये मिश्रण अनपैक्ड डिटर्जेंट पाउडर के रूप में तैयार हो जाता है। इस मशीन को चलाने में छोटे सेटअप के लिए 10 हॉर्स पावर बिजली की आवश्यकता पड़ती है। डिटर्जेंट पाउडर यूनिट स्थापित करने के लिए GST रजिस्ट्रेशन, MSME रजिस्ट्रेशन, उद्योग आधार रजिस्ट्रेशन, ट्रेडमार्क रजिस्ट्रेशन इत्यादि की आवश्यकता होती है। पैकेजिंग करने के पहले इस बात का ख्याल रखें कि एक पैकेट में कितना डिटर्जेंट पाउडर देना है। आप 1 किलो का पैकेट बना रहे हैं या आधे किलो का, इसका ध्यान रखा जाना जरूरी है। पैकेजिंग करने के लिए सीलिंग मशीन का इस्तेमाल करें। इस मशीन से पैकेट बहुत अच्छी तरह से बनता भी है और देखने में आकर्षक भी लगता है। जहाँ तक मुनाफे की बात है तो प्रति किलो डिटर्जेंट पाउडर बनाने के लिए आपको कम से कम 25 रुपए लागत लग जाती है। अगर आप ये डिटर्जेंट पाउडर 40 रुपए प्रति किलो के हिसाब से बेचते हैं तो आप 1 किलो पे 15 रुपए कमाते हैं। अगर आप 200 किलो पाउडर एक दिन में बेचते हैं तो आप रोज के 3 से 4 हजार रुपए आसानी से कमा सकते हैं। यानी आपको महीने की 60 से 70 हजार की इनकम हो सकती है। डिटर्जेंट पाउडर बनाने के व्यापार की मार्केटिंग के लिए आप रिटेल और होलसेल दोनों तरह की मार्केट का इस्तेमाल कर सकते हैं। डिटर्जेंट पाउडर के जरिए आप एक ऐसा व्यापार स्थापित कर सकते हैं जो लॉन्ग टर्म बिजनेस साबित हो सकता है और आपको लंबे समय तक भरपूर लाभ दे सकता है। तो अगर आप भी डिटर्जेंट पाउडर मैन्युफैक्चरिंग के साथ अपना एंटरप्रेन्योरशिप का सफर शुरू करना चाहते हैं तो जुड़िए IID यानी इंस्टीट्यूट फॉर इंडस्ट्रियल डेवलपमेंट से। IID आपको आपके बिजनेस की कोर एक्टिविटी की पूरी जानकारी, एक्सपर्ट्स एपिसोड्स, बैंकेबल प्रोजेक्ट रिपोर्ट और लाइव वर्कशॉप प्रोवाइड कराता है और साथ ही आपके बिजनेस के रजिस्ट्रेशन में आपका पूरा सहयोग भी देता है। तो क्या आप इस अपॉर्चुनिटी का लाभ उठाकर एक सफल उद्यमी नहीं बनना चाहते? इस अपॉर्चुनिटी को ग्रैब करने के लिए आप हमारे कॉन्टैक्ट नंबर्स और लिंक्स के थ्रू हमसे संपर्क कर सकते हैं।
Good grammar and spelling are
Okay, so that's about it. I think some of you should try, with some camel milk or something, soap making at home and show a demo of it, right? It's a very creative process. There is not much of, complicated equipment required. There are many homemade soaps also, remember, and I'm sure You can give a try. You saw they did with some olive oil, castor oil, avocado oil, and you could make a list of it and make your own choices soap. Okay, so there is a lot of entrepreneurship possible in soaps and detergents, and I'm sure some of you will have a go at it, and let's hear about it. Okay, so thank you all, thank you, and tomorrow we will get into edible oils and essential oils. Okay, so thank anyone from Kannauj? Is there anyone from Kannauj? Okay, thank you all.